On my workbench, I have a fuel injector tester, and it's here because it's not working. So let's confirm its lack of operation. These are pretty straightforward. All you do is hook them up to a battery, and then you'd hook this end to a fuel injector, press go, and then this little output light should light up and blink, and it'll pulse your fuel injector. And it's a really nice test tool to be able to, you put a fuel pressure gauge on the vehicle, and then you prime the system, activate the tester, see how much it drops. You can compare the fuel injectors to each other, see if there's a leaking injector, make sure that the injector is actually working. Nice little diag tool when it works. So let's take a second here to confirm, even though my output light's not working, let's confirm that there's not actually any output from this. I have a scope set up here. You don't need to go this fancy. You could just use a light bulb, and it wouldn't pulse, it wouldn't show you the signal, but it would turn on. I have absolutely nothing coming out of my injector tester here. So let's confirm I've got everything set up correctly with a known good injector tester. Here I have an injector tester of a slightly more questionable quality level. And I'm going to set this up, let's see here, on my power, plug in my power, plug in my ground, and now when I press pulse, I get a waveform here. So that indicates to me that this tester is working properly. And if you don't have this isn't a very high-end scope, but if you don't have a scope, you can go a little bit more basic with something like this. You should have a test light laying around somewhere. I mean, if you don't have a test light, even something as simple as a light bulb out of a tail light or a light bulb out of a license plate would work. And now, careful in this situation not to short out your leads. I have a suspicion that that's what happened, and that's why the other injector tester is on my bench right now. And when I press pulse, you should see the test light light up. It can kind of, I don't know if the camera's picking that up. It is pulsing a little bit, but it's an incandescent bulb. It's not going to turn on and off the same way that a fuel injector would. So you can hear that. You can hear that fuel injector. That's what it's supposed to do. And that's the purpose of this little tester. And there's a couple of different modes that we could pick for different speeds and different durations, which is pretty cool. That's neat. Right here, just in case you're a visual. So you can see the signal, and you can hear the injector being activated. And each time it's pulsing right there, that's each time it activates. That's kind of neat. I would highly recommend, so you can see here mode 4 is a continuous. I'd recommend being very careful with that, because if this is attached to a vehicle, that's going to dump a lot of fuel into the cylinder. It would be good for a cleaning mode though. And do be very cautious hooking a scope up to an injector. When this is powered by a battery on a car, this injector gets 12 volts to it, but it creates, inside this injector is a coil, and it creates a magnetic field to open the solenoid. And when that magnetic field collapses, that's going to kick about 80 to 100 volts back to your scope. So make sure that either A, your scope can handle that much voltage, or if it can't, make sure that your attenuator is set to 10x, so that it's going to take that 80 volts, 100 volts, basically divide it by 10, and send a smaller voltage signal into your scope. All right, let's get this pulled apart and see if we can't see what's going on. Okay, it's kind of neat looking at the inside. Like, what makes this thing go? What makes this thing tick? So we have a switch. We have what looks like a couple of variable resistors in there. Some LEDs. We have a transistor. We have a logic chip. We have some resistors, capacitors. Those look like ceramic capacitors. Some diodes in there. Some more diodes. I believe that to be a capacitor, and you know, I'm not 100% certain on what this piece is right here. I'll have to look that up. That's kind of neat. Anyhow, it's a pretty basic circuit. So this is my input wire, and then this would be my output. And my light was lighting up, stating I had power, but I had nothing coming out. So if we have a look, well, that one was a pretty straightforward, easy to see problem. We are missing the trace, or more correctly, what I should say is this trace right here got burnt. How does that get burnt? Well, very likely that this connector here did not line up. Where'd my injector go? Injector, come back! More than likely, this connector did not line up with the injector that was trying to be tested, and when they made a jumper lead for it, they didn't take the time to make something as precise as this, and this was really inexpensive. Like, you can buy kits of these. They're really, really nice. They're, you know, they can range from like $200 to $700. This was a Amazon kit of pins, a little bit of shrink tube, and some silicone wire. You'll notice how flexible that wire is. The silicone-based wire-based insulation is used in your tooling because it will take a lot more flexing than what a PVC one will before it breaks. And then this is really nice because I've got my two connectors there that I've insulated, so I can just attach those directly to the pins on the fuel injector there. And then my other two ends go right in to my test end there. And I mean, it's still possible to short things out, but with a little jumper lead made like this, it makes it much, much more difficult to do that. And I got a few other different designs that I just kind of make these as needed. Some of them hook right up with a banana connector to my meter, and then the other end has a pin on it for back probing. You just make whatever you want. Your imagination is the only limit on your creativity. Very, very useful little tools. So we need to fix this trace. Now, for cleaning this green enamel off of the traces, they make these little fiberglass pens, which are quite handy. You do have to be very, very careful. This is a fairly thick trace, so you could probably get away with using a knife or a sharpened screwdriver. Yeah, see, that's working okay there. Some traces, especially as you get into the more precise, the finer electronics, they're very thin, and if you were to use a knife or a screwdriver, you're just going to take the whole trace right off. So be very cautious when you're working on electronics, especially the smaller, more intricate boards. This one is a fairly basic one for a fairly modern tool. And I guess, you know, worst case, we could just go solder right from this pin here over to this pin. But we're not going to have to do that. Let's clean a little bit more of that enamel off. That's not so bad. Okay, cool. Well, I can't solder that one back together. Like that wouldn't work. There's not enough copper there. Now, sometimes, depending on what I'm trying to do, they do make enamel wire, which this stuff is really good for bypassing traces. And if you've got to travel a distance on a board, this is nice because it's coated, so it's insulated. However, for such a small repair, I'd have to strip all that insulation off. So I'm just going to use a piece of solid strand wire, and I'm just going to strip it back a little bit and use my wiring. That should be more than enough. Apparently this spool had some gook on the bottom. I'm going to take my little piece of wire here and just kind of bend it to match the trace. And I just have to be careful. I don't want to over solder, because if I touch those other two connections right there, I'm going to short the circuit out, and I really don't want to do that. Just a tiny, tiny little bit of flux on there to help that solder flow. And I'm using, I got the good stuff here. This solder's got some lead in it, so it's got some rosin in it. So this is a flux core solder. Take my soldering iron, tin my tip just a touch. And really, that's probably about as much of the solder as I'm going to need. Tin those little ends right on the board. Whoop. Try this again. Down. And when I heat that up, close. It's arguing with me a little bit. That'll happen. I don't have the rock steady hands of a brain surgeon, that's for sure. I had it pretty well where I wanted the first time too, that's too bad. There we go. So now, I'm okay if I touched this little post here, because that was the trace that I was repairing. I did not connect it to either of these two. Let's see if I can get a closer look. So we're in pretty good shape there. This little piece of wire that I added is connected in. It's okay if I touched this post, couldn't touch these two. This is part of the trace that I'm repairing. So I can trim that down a little bit. I mean, it really wouldn't be in the way of anything there, but ha! That worked great. Glad that I showed you that. Okay, well, let's get a better close-up on that solder then. That's what that gives me the opportunity to do. See how that is. That's a little better. Always good to check your work. Okay, cool. I'm just going to use my flush cut pliers here. Trim that up. There we are. Not the prettiest thing I've ever seen, but it's not terrible. And then anytime you use some flux, it's never a bad idea to take a little bit of isopropyl alcohol and just clean the flux off. You probably could leave the flux there, but it does become acidic over time and it can cause corrosion on the board. You never know how long the tool you're fixing is going to be in service. Okay, let's test this out. Alright, so I'm still connected to my fuel injector. We know that was a working injector. Let me get my battery. How do I lose stuff when I didn't even get up? There it is. Okay, and we can see the LED for the power is lit. Let's get this back. I don't have to put everything all back together just yet. Okay. Survey says, did you hear that? We are working. And you can see that my output LED is flashing. Let me get this back together real quick and then I'll confirm it again. I'll show you what it's going to look like now that it's good on the scope and with a light. Probably should have disconnected that from the power before reassembling. Yeah, I'm just running extra tests, that's all I'm doing. Okay, cool. Still works after assembly, that's nice. Always a bonus. I've just added in another set of my jumper cables here purely for testing purposes. There's no practical use of this, but this is just to get me a better access point here. To then be able to show you on the scope what we're looking at, which is pretty cool. It's neat to have some of these tools to be able to do these types of things and just kind of get a nice visual of what's happening. However, again, you don't need to have a scope to make this confirmation. Just a simple light bulb. And we can see there that our tool is working just the way that it's supposed to be. So we're in good shape, fix the tool, save the shop a few $100, and hopefully that mistake won't be made again. So I hope you found this helpful. I'm going to put together a video for you pretty soon on how to use this sucker on the car. Stay tuned for that. Thanks for watching.